Hi dear friends, good morning to everyone. Dear friends, in the next part of in the previous part of the video, we tried to discuss some introductory part of syllabus in the second semester of the first year BSc, and we came to know that just like the semester first, there will be again 3 units in the semester 2 also. Semester 1 will be based upon the physical chemistry and it will contain the topic. The first topic is ionic equilibria, second one is solid state chemistry, and the next one is molecular spectroscopy. Again, the unit number 2 based upon inorganic chemistry, while the unit number 3 will be based upon organic chemistry, and definitely it will be again study of stereochemistry second. Dear friends, in the unit number first, as there are 3 topics based upon the physical chemistry. Now in this online video lecture, we are going to start the first topic or the important topic of the unit number 1, which is entitled as molecular spectroscopy. Here, just like the semester 1, we are going to start our lectures through online video lecture series, because as you are aware that as we completed our earlier semester through the online mode of teaching, and we have successfully completed our exams also. Now dear friends, in this semester also we are going to start our syllabus through the online video lecture series, and in this lecture we are going to start our actual syllabus from the topic of molecular spectroscopy. Dear friends, if we'll talk about the molecular spectroscopy, then definitely it is very essential to study some basic terms in the molecular spectroscopy. What is molecular spectroscopy? What is spectroscopy? Whenever we are going to talk about the molecular spectroscopy, first of all, you should know what is spectroscopy. Spectroscopy, it is a study of responses given by the different species, either atom, ion or the molecule, whenever these are exposed to some kinds of the radiation, particularly electromagnetic radiation, and the study of that responses is called as spectroscopy. And if these responses are given by the molecule, then it will be called as molecular spectroscopy. Based upon the molecular spectroscopy, definitely we would like to discuss some history as well as basic concept in the molecular spectroscopy. And whenever we look at the discussion of this molecular spectroscopy, then you will come to that this scientist who is known as James Maxwell in the year of 1865 proposed that light and other radiations are transmitted through the space continuously in the form of electromagnetic radiation. So what is electromagnetic radiation? That is also important, but he has proposed that light and other radiations are continuously transmitted through the space in the form of electromagnetic radiation, and these electromagnetic radiation or these waves consist of the two oscillating component. One is electric component and another one is the magnetic component, which are directed perpendicular to each other. So these radiations or these waves consist of the two oscillating components. One is electric component and another one is magnetic component, and these two components are perpendicular to each other, and that's why these waves are also called as the electromagnetic radiation. Again, it is also found that these waves or the electromagnetic radiation are perpendicular to the direction of propagation. So this is also important. So not only these two components, electric and magnetic, but these waves are also perpendicular to the direction of propagation. And the examples of electromagnetic radiations are radio waves, visible light, X-rays and the gamma rays. So these are some radiation which has both the component electric and the magnetic component. That's why these are called as electromagnetic radiation, which are perpendicular to each other, and these are also perpendicular to the direction of propagation. Again, It is also proposed that this electromagnetic radiation have a dual nature. It has dual nature, meaning it shows the dual property, two properties. One is the wave nature, another one is the particle nature. Definitely, this wave nature as well as particle nature is supported by various or the different experiments, and then it is observed that this photoelectric effect suppose the particle nature of the light, while the wave nature of this electromagnetic radiation or the wave nature of these radiations is supported by the phenomenon like reflection, diffraction, and destructive interference. So here this is very important. So particle nature of light is supported by the photoelectric effect, while the wave nature of the electromagnetic radiation is supported by the phenomenon of reflection, diffraction, and destructive interference. This is important. If we look at the various characteristics of this electromagnetic radiation, which are very important in the study of molecular spectroscopy, then already we discussed about the dual nature. That we are already discussed about the uh, properties or the components of this electromagnetic radiation. So this electromagnetic radiation has two components. One is the electric component, another one is the magnetic component, and these components are perpendicular to each other. So not only these two components are perpendicular to each other, but these waves are also perpendicular to the direction of propagation of these radiations or the waves. It's very important. And it is also found that the electromagnetic radiation travel with the speed of light 3 into 10 raised to 8 meter per second in vacuum, and definitely their speed also reduced or changed on the basis of medium through which these waves are passing. So here the speed of radiation, particularly electromagnetic radiation, depends upon the nature of the medium through which these waves are passing. Again, these electromagnetic radiations are able to transmit energy through the space. So all electromagnetic radiation can transmit energy through the space, and already we discussed about this. Another important characteristic of this electromagnetic radiation is that this electromagnetic radiation shows the dual nature. One is the wave nature. So this is the wave nature, and another one is the particle nature. So here this electromagnetic radiation shows a dual nature. One is the wave nature and another one is the particle nature. Wave nature is supported by already we discussed about the wave nature, how this wave nature is supported by the various phenomena, and as well as particle nature is supported by the photoelectric effect. Again, as these electromagnetic radiations are showing the wave nature, and that's why it shows the wave properties. So here the different wave properties of electromagnetic radiations are discussed here. One of the properties of wavelength. Wavelength, this is the wave property of electromagnetic radiation. So whenever you want to define this property, this is simply the distance between two successive crests or the trough. Because whenever any wave is passing, definitely it has this type of the nature. And whenever you want to discuss about the distance between two successive crests, this distance and this distance, or distance between two successive, that is nothing but the two successive trough, means this distance, then this much distance is called as the wavelength. So it is, this wavelength is always indicated by means of an Greek word lambda, and most commonly used units of the wavelength are meter, centimeter, nanometer, micrometer, etc. As it is a distance, so definitely it will have the units of distance. Electromagnetic radiations having all waves of single wavelength are called as the monochromatic radiations or the monochromatic light. So those electromagnetic radiations which are having a single wavelength, these electromagnetic radiations are called as monochromatic radiations. And if these electromagnetic radiations consist of the waves of different wavelength, then that type of the electromagnetic radiations will be called as the polychromatic radiations. I hope you got the meaning of the distinguishing between monochromatic and the polychromatic. Monochromatic radiations having the single value or the single wavelength, while the polychromatic radiations consist of the radiation of different wavelength. Another wave property of electromagnetic radiation is called as frequency, and this frequency is simply defined as the number of waves. It is simply the number of waves passing through certain point in a 1 second. So how many waves are passing through a certain point in 1 second, that number of waves are called as frequency, and again it is indicated by the Greek word nu. The most common units of the frequency is called as hertz, indicated by means of this symbol, kilohertz, megahertz, or 1 Fresnel. And remember that 1 Fresnel is equal to 10 raised to 12 hertz. So this is another wave property of this electromagnetic radiation is called as wave number, and this wave number is simply the reciprocal of the wavelength. That's why it can be defined as the number of waves per centimeter or per meter in vacuum. So number of waves per centimeter or per meter is called as the wave number, and definitely it is a reciprocal of the wavelength. So this reciprocal of wavelength is also called as the wave number, indicated by this nu bar, and it has the unit of reciprocal of distance. That's why it is always expressed in per meter, per centimeter, per nanometer, like this. So this is the unit of wave number. Another wave property of this electromagnetic radiation is called as the velocity. So this velocity, whenever we want to define the velocity, it is simply the product of wavelength and the frequency of waves. So product of wavelength and frequency of waves or the electromagnetic radiation is called as velocity of wave, and it is always indicated by the letter C, and it depends upon the medium through which it passes. Already we discussed in the characteristic. The relationship between the wavelength, frequency, and the velocity is given by the equation that this frequency is equal to the ratio of velocity of light to the wavelength of light, and that's why from this equation we can write this C is equal to mu into lambda. But this mu actually not mu, it should be the mu bar, but this mu bar is what? This mu bar is the reciprocal of wavelength, and the reciprocal of wavelength is called as wave number. That's why whenever you want to define this, then therefore this equation can be also written in the form of this equation, that mu is equal to, that is C into 1 upon lambda, but 1 upon lambda is equal to mu bar. That's why this equation, wave, or that is frequency, is equal to wave number into velocity, can be also derived for the relationship between wavelength, frequency, and the velocity in terms of wave number also. So dear friends, here in this part of the video we try to discuss the various terms in the study of molecular spectroscopy, and we also try to discuss some characteristic and the wave properties of electromagnetic radiation. So this is much more important in the study of molecular spectroscopy, and in the next part of the video definitely we would like to discuss different types of electromagnetic radiation, which shows interaction with the different molecules, and it shows different phenomena in the molecular spectroscopy. So dear friends, we will resume in the next part of the video to discuss about the different types of electromagnetic radiation in the form of electromagnetic spectrum. So dear, thank you very much.